Hi and welcome to Geeks for Geeks. Today we would be discussing the problem container with the most water. So here you are given, you can imagine them as a rod, okay, as a rod which are straight but they don't have any width. And then you would be given the height from the x-axis till the y-axis. So this one would be fixed that it would be 0, 0, 0, 0, 0 and the height would be given together with the x-axis. A single vertical line would not be able to hold water. It is given. So before I tell you these all sample test cases, let us first take a very simple idea. The very first one is how much water can it hold? See, if and you can't really slant the whole thing. So if I just have a water over here, because if I have water above it, it would spill. So if I just have water above here, the height is 5. This part would hold the water. And how much width of water I can hold? 5 multiplied by 1, 2, 3, 4 and 5. That is why the answer is 25 itself. So now you understand now. Let us go back to this. So now if I have a height of 1, 5, 4 and 3, so I can simply use 5 and 3 with a distance of 2. So the minimum height, like I would explain you with an example. So let's imagine this as a height of 5 and this is a height of 3 and this is in between height of 4. So water would be contained in this part. This is how you have 3 multiplied by 2, that is the value 6. Let us see more. Then we have something like 3, 1, 2, 4 and 5. Let us visualize that also. So we have a height of 3, we have a height of 1, we have a height of 2, we have a height of 2, we have a height of 4 and we have a height of 5. So here the water would be held in this section. So 3 multiplied by 2, 3, 4. 3 multiplied by 4, the answer is 12. That is why you have this. Last example would be a homework for you. Otherwise, this would be very big enough. I told you an alternate example to this. Fair enough. So let us try to think how we can solve up this problem. So if I see this problem, if I just visualize this problem, this would be the kind of figure with the correct ideas. So the very first scenario I can think of is that here the width influences, here there are two factors that would influence the amount of water. The very first one is the height, and the very next factor which would influence the height is the width, and the answer would be nothing but height multiplied by width. So both of the factors would influence, okay, and both are directly proportional. If the height would increase, the width would also increase, okay, like the amount of both are proportional to the amount of water. Height increases, amount of water increases. Width increases, the amount of water also increases. So we need to maximize both of this. It's not like we find the maximum height and the second maximum height and we just have water in it. Okay, it's not finding two maximum and keeping water inside. So now what would be the scenario? And the next observation is that if there are two pillars and we want to keep a water in between it, the height would be nothing but minimum of left and right pillar multiplied by the width. This is the second observation I can make. First I found out the factors, then I had the observation that we can draw. Okay, and multiplied by width, that would be the same. How can we if we know that I want to calculate this one and this one, then the width would be nothing but right minus left. So I can simply say that the width is nothing but right minus left. So this is the third observation. First one is factors, next one is minimum, and the third is width. Fair enough. Now we have a fair gain of idea. So now what we can do is we can consider pillars like this. Like this pillar, I would try to pair it up with this pillar. Then I would try to pair it up with this pillar. Then I would try to pair it up with this pillar and this pillar, this pillar, this pillar, and this pillar. I can do that. So for all I can have its pair as I plus 1 till n minus 1 for all I. Like I would stand, like let's see if I am standing at this and this pillar has already been considered by when I was considering this pillar. So not to have duplicate, so I can, if I'm considering this pillar, its pair of pillars would be nothing but these all pillars. Like this pillar would make a pillar with this pillar would make a pillar with this pillar would make a pillar with this and this and this and this. This is how this pillar would make up pillars with others. That is why I said this, that for all I you need to consider I plus 1 to n minus 1. So now we have the brute force approach. What we can do is we can simply, for all i's we can consider all j's, and the width would be nothing but j minus a as we have noted. So now it's like for one pillar, in the worst case we would be considering n minus 1 pillars as a pair of them. So for n pillars we can say that we would be doing big O of n square operation, and the space complexity would be constant because you are using variables, and variables don't account to big O space complexity. Okay, we found an n square approach, the brute force approach. Now let us see if we can use up these all ideas and influence it better or not. So see, can I do something like this? Like see, width is very important. So first I would try to have the maximum width. So this side is 2, this side is how much? 5. So minimum of 2 comma 5 is 2, and multiplied by the width is 7 minus 0 is equals to 7. So now I know that if I consider the extreme left and extreme right pillars, I would be able to keep 14. So I would say answer as of now, the best answer I have found is 14. So now I know that I want to increase this value. I want to increase this value because this is not the answer. So now, as of now, we have, so what does it influence? It influences what I can say, that minimum of left height comma right height multiplied by the width. So width is maximized at this point. Width is at its peak at this point. Next what we can do is we should try to maximize the minimum. I'm just having it in the intuitive fashion. Just think it intuitively. Width is as its peak, so we can't really touch the weak. We have only one component, and that one component is the minimum of left and right. If the minimum of left and right is increased, then we might find something better. If the minimum of left and right is increased, then we might find something better. So as of now, the minimum here is 2. Here the minimum here is how much? 5. So if I want to see a growth over the minimum, I should try to increase this value, because this is what would affect this side. This is what would affect this side. But this does not really guarantees that if we move to the right hand side, the values would increase. Why? Because the values are not sorted. But still there is a hope that we can find a better partner for 5 apart from 2. Even if it is good enough, we have updated the result. Even if we find something bad after this, that is, even if we just move forward and we found 1, and now 1 comma 5 is 1 only, and 1 multiplied by 7 minus 1, that is 6. So we have found 6. So even if it is bad, no issues. It won't affect the answer because 6 is less than answer, so we won't update it. But we're just walking on hope. We know that 2 and 5 is good enough. Even if we increase the 5 to 6, the answer won't change. Even if we increase the 5 to 500 also, the answer won't change. So the only thing we can change is the minimum. So now let us try to think more. Let us try to go more, because this side is still the minimum side. Let us try to go more. Now this time I have a good one, that is 8. The minimum of 8 comma 5 is 5, and the difference of them is 5, which is 25. So now by just doing a dry run of this approach, you can see that yes, we have landed it correctly, Siddharth. So this is how you can build out the intuition. Build out the intuition and see if it is working for at least the sample test cases or not. Then now 8 and 5 are there. So this time Increasing 8 further would be of no point. Why? Because even if we increase further, the minimum of that would still remain 5. So now we would increment the 5 and then see again. We have still received 5. No issues. It won't affect the answer if we have a decremented value. So 5 multiplied by 6 minus 2, that is 4. So this time it is 20. It won't affect the result. Now again 8 and 5. There is no point in moving 8. So again we would move 5. So now this time it would become something like 6. So 6 multiplied by 3. 5 minus 2 is 3. We have 18. And that value is again less than 25. Again, the value that is less is how much? 6. Minimum one is 6. So we should again move forward. And this time the value gets decreased to 4. So 4 multiplied by 2 is how much? 8. Won't affect the result. Don't worry about all those. Okay, Siddharth. Now again 4 is less. So again move forward. We have something like 6. So now 6 multiplied by 1 is 6 only. It won't affect the result. So now just doing the dry run and we found that this approach is correct. But how I would convince myself that yes, this would work? The convincing factor is that what can you do? You can maximize the width, and after the width is maximized, the only point is that you maximize the minimum. And doing operation with the greater one would be of no use if minimum is minimum only. So that is why we try to alter the minimum. Altering the minimum can be what? We can just move this side, then just move this side in a hope of finding a better side. So this is indeed the better idea. What we would do is, the approach is that we would have the value of L and R at its extremes. Then we would calculate the width as R minus L. And then we would have answer is equals to the minimum of A of L with the value of A of R multiplied by the width we have up till now. Then whichsoever is minimum, we would do, if L is minimum, we would do L plus plus, else we would do R minus minus. At the end of the day, we would get the answer. This is how you can solve up this problem using 2 pointers. I know this is non-intuitive, but if you write down the equation and then try to think it on that terms, then it would become intuitive. Now let us see, if I implement this, what would this approach look like? So as told, we would have left is equals to 0 and R is equals to length of that minus 1. Then the result up till now calculated is 0, and we would keep doing that until L and R don't cross each other. So we would calculate the minimum multiplied by the width. Okay, we would update the answer if needed. If the answer was already more, it won't update. Then if the left is less, we would increment the left. If the right is less, we would decrement the right. And the max of that would be our answer. Let us see if this approach really works or not. Let us run for the sample test cases. And yep, this works fine for the sample test cases. Let's just submit this and see if we can get an AC or not. And yes, we got an AC. Let's talk about the time complexity now. We are having left and right, and each number would only processed by once. And if they crash, they are bound. So each element is processed once. So it is big O of n. Talking about the space complexity, we are not using any auxiliary space and variables don't contribute. That is why it is big O of 1. So that was it for today. Thank you and have a nice day.